In this video, I'm going to show you how I use Cursor to do some data analysis. Let's get started. Okay, so here we are on the interface of Cursor. It looks exactly like a VS Code if you're familiar with it. I am currently on a folder called Analysis, and in this folder, there's just one data file. It's a CSV. It is a motor vehicle collisions crashes. You can see that maybe every line, every row is a crash that has date and time, location information, and also number of people that are injured and killed. Okay, so we're just gonna ask Cursor to analyze all of these for us. So here is what you need to do when you initialize Cursor. You want to open all the views that Cursor has. So here you click on View and then Open View. At Open View here, you want to scroll down and find Composer. If you click on Composer, it's going to show up in a second panel. Here, there's Chat, there is Composer, and there is Bug Finder. For now, we're just going to use Composer. And then there is a very small text right down here. There's normal and there's agent. So a normal mode, Cursor is going to write code for you and you need to accept or not accept them. But if you click on agent, an agent mode is going to write code for you and run it for you. If it runs into bugs, it is gonna debug and rerun it until it's successfully ran through. So this is what we want. We want to have use the agent mode for now. Okay, so I'm going to tell Cursor what I want. I'm gonna say that there is a CSV file in the folder for analysis. First, write a loader file to directly load it. And I say that I do not want to manually write the file name, so please pick it up by yourself. And then secondly, I wanted to write an analysis file to do some summary statistics and EDAs for each column using Python. And I wanted to put the results in a markdown file. And I said, if you made any figures, please put them in the figures folder and then load these figures on the markdown file. And I'm gonna hit run and see what happens. Okay, so it says I'm gonna give you a very structured analysis project. Let me break this down into two steps. First, I'm gonna check the directory structure and create necessary files and folders. It says I'm gonna create these files, so it's gonna create a directory for me. I'm gonna click run, and then it continues. It says now I'm gonna create this loader file. Okay, so the loader file is written. You can see that it has several functions, and at the end there is a main function that loads the file. And then it continued to open another file called the analysis file. At the top, you could see that there are all these standard data packages like pandas, numpy, matplotlib, and it also has the loader that we just wrote, right? Okay. So it is done. Cursor says I've created a complete analysis setup with loader and analysis, which did all these things. And I'm gonna click accept all. Would you like me to create a requirement files? And I would say yes. Create analysis, create requirements as well, and run the analysis. Is agent mode already? Okay. All right. So it has generated a requirement file for me, and it ran the analysis. And it says, now let's run the analysis. Unfortunately, it ran into bugs. It says file not found. Oh, what happens? It says, I see there's an issue with the Seaborn style, so let me fix the analysis file. Okay, so apparently it changed the style of Seaborn. Now it's running this analysis file all over again. Okay, so it's done. It says the analysis has completed successfully. You see that it ran into bugs. It reads the bugs message and debug and rerun the analysis until it's done. And it says, okay, now I have a figures directory. It has all the figures that I needed. And it has a results markdown file with a comprehensive analysis, including dataset overview, summary, value counts, and embedded visualizations. So yeah, let's take a look. So you can right click results markdown and open preview. All right, so the analysis are here. There's number of rows and number of columns. We have column names. We have summary statistic. This is probably too large, so I need to zoom out a little bit. And I can see that, for example, zip code, latitude, longitude. Number of person injured is a number from 0 to 13, and it has an average number of 0.57. So it means that crashes are overall very dangerous. On average, 0.6 people got injured in every crash. It also has number of persons killed. This number is from range 0 to 1, with an average of 0.0019. So this is saying that on average 500 crashes, there will be one person that is killed. Okay. All right. And then if we come down, we see that there are top values for crash date, top values for crash time, obviously in midnight or 6 p.m. At 9 a.m. there are most amount of people that are that have crashed. And then also top values for borough. Oh, so Brooklyn has the highest amount of crash in this data set. Zip code figure is not really visible. This is probably because there's a empty space in here. So I'm gonna start giving feedback for the cursor agent. And the first feedback is some figures are not showing on Markdown because file name has spaces in it. This is probably because the variable name has space. I assume the agent can find it out, but I'm just gonna be a little bit verbose here and tell it that because space in variable names. So this is my first feedback. The second feedback is the distribution of latitude. You could see that most of the latitude is around 40s-ish, but the distribution is all the way to 0. So my guess is that there are missing values that are miscoded into 0. And you can see that with longitude as well. So I'm just gonna say for 0 in long and lat, they are actually missing. So convert them to missing or none before drawing visualization. And then we see top values in Borel. This looks good, so there is no extra feedback. So we're just gonna give these two feedback and see if they cursor can fix them on its own. Okay, so it says I'm gonna modify the analysis script to handle these issues. It is editing the analysis file. It says I have made the following changes. And then start running the analysis file after you made the changes. And it's done. It says I have updated it. You can now check the results in the markdown file. So let's come down and see. There you go. Now we can see the zip code distribution. And we can the most amount of here. I'm assuming these zip codes are probably Brooklyn zip codes. And then a distribution for latitude. This looks much more makes sense now, right? And a distribution of longitude, because the distribution is more makes sense now because we have converted the 0 values to missing, because they're probably just missing values. We have distribution of number of people injured. This is a very skilled distribution, so this chart doesn't really tell a story. And we also have number of person killed. This is even more skilled, so the chart is not really helpful. It also have top values in crash date. This is actually not what I wanted, right? In an actual analysis case, I want a time series chart that has a time series line. So I am going to go on and tell cursor that the next step is to time series analysis. And more specifically, I want to know if the congestion pricing program that started in January the 5th has any effect on crash, whether it's number of crashes or number of people that are injured. So we're gonna come here and say, next, do analysis on congestion pricing. It is implemented on January 5th, 2025, 12 a.m. I want to see daily time series charts of daily crashes and daily injuries. And I also want to see a vertical line of the congestion pricing start on these graphs. Okay. So the assumption or the hypothesis that you have as a data scientist is you want to know if there is an impact on congestion pricing on public safety. And if there is less cars, maybe there will be less crashes and less injuries. Does it affect everywhere? Probably not. Probably only the part where the congestion pricing started. But what if there are less cars in other areas as well? So I'm doing a overall analysis right now. Apparently cursor is running into some bugs and it is fixing them. And it's run into the bug for the second time. Okay, it looks like the analysis is complete. Let's see. Um, we're still on the result file and everything still looks the same. We'll come down here. There is a congestion pricing impact analysis. Oh, here we go. The first is daily number of crashes. We could see that there is a downward trending line way before the pricing program started. And then it sort of just stay at a noisy level, but relatively the same level. And it has a downward trend at the end of the time series. Similar thing for injuries and fatalities. Actually, fatalities is not really visible. So, so this is not enough, right? This is not enough for us to draw any conclusions. It also has average statistics. This is nice. I guess one thing that we can do here is something similar to a difference in difference causal analysis, right? So for example, before congestion pricing, you could see that average daily crashes is 227. After it's 195, so there's a decrease. Daily injuries also decrease from 133 to 108. Daily fatalities stays the same. And then percentage changes. You could see that daily crashes goes down by 13%, daily injuries goes down by 18%, daily fatalities by 2.9%. So this is not enough for us to draw any causal conclusion. But what if we compare areas that are directly affected and areas that are indirectly affected? The reason why I say they are directly affected and indirectly affected is because if one area is imposed by some kind of program, people who drive into these places are gonna stop, but they might also stop driving in areas that are outside because the purpose of them is to drive inside, and now they just stop driving overall. That might be one of the reasons, but there could also be other factors of it. So I want to do difference in difference. And so then I need the agent to figure out a way to codify the areas that are actually affected. And remember, we have zip codes. So let's utilize that. Do difference in difference analysis. The first difference is before and after. So create a dummy that equals to 1 if January 5th, 2025 or after. The second difference is Manhattan below 60th Street. So generate a dummy that equals to 1 if zip codes are below 60th Street, and equal to 0 if zip code is not missing. Remember at the beginning, it says that zip code or longitude or latitude has some missing values, right? If zip code is not missing and borough is Manhattan, and that's it. Okay. So I also want the agent to go online and cross-check the zip codes that are assigned to 1 are indeed below 60th streets. So a difference in difference is something that the economics PhD students would do. So here I'm actually asking the agent to do something as sophisticated at that level, even though it's still very simplified in this way. So the agent says, I'm going to go into create difference in difference analysis. First, let me find Manhattan zip codes below 60th Street. According to New York City data, Manhattan zip code below 60th Streets are these. Uh-huh. I actually think 10023 is Upper West Side, so it should not apply. It runs into some code. It says cannot insert column. So it starts, okay, it starts debugging. And now let's run the analysis again. Analysis complete. Let's check the output. So it added a new section called difference in difference analysis. The treatment definition here is after January 5th. Location treatment is below 60th Street. It has a parallel trend visualization, which I don't really see two parallel trend, unfortunately. It should have 2 lines, right? The first line should be control zone and treatment zone. So here, obviously, cursor is not doing what I'm asking. Okay. So cursor is not doing what it's supposed to do. I am going to check the file to figure out why it is not. Um, I'm gonna check that. This is actually a little bit hard to find. Okay, I'm gonna check. Where in code did you create the dummies? Okay, so it says preprocessed data, there is defined post congestion that equals to 1 if crash date is larger or equals to January 5th, 2025. So this looks good. The second dummy is Manhattan below 60th Street. And apparently, I think one thing is wrong, that is this. So I'm going to say remove 10025. 23. from below 60th list. And then I'm also gonna see in treatment zone is the dummy is borough equals to Manhattan and zip code in there. Okay, so that means treatment zone. Okay, so the first thing is I'm gonna say remove that. And then the second thing is print out two dummies for me and see why. Distribution of post congestion is correct. There is 0 and 1. The problem is why treatment zone variable is completely 0. I have some hypothesis. I think that if that variable is completely 0, maybe the dummy isn't created correctly. So I think maybe this is not created. Yeah, this is probably not created correctly. I have two hypotheses. Maybe because these are strings. So it's still failing. Yeah, it's still failing. I don't understand. I think it's because they are string. Yeah. So it is debugging. Oh, I figured it out. Let's see. So it did figure it out. It did look into this whole thing and find out that, see the distribution of treatment zone. Now I have a treatment and control group. Yeah. So it fixed the zip code issue because previously zip code, it says that previously zip codes are stored as float, now properly converted to string and cleaned. And so the bug that we just show is an evidence that you need human in the loop at current state of the cursor. Okay, so we have distribution of different diff treatments. And I want to see the impact. Okay, there you go. You have treatment zone and control zone. These two lines are too far away. I don't see a parallel trend, unfortunately. But if you just look at the t-test, it's not showing in t-test actually. But you could see that, oh, in treatment zone, let's say before is 14, after is 11.6, 0.06, so the difference is -3. In the control zone, there is actually a larger decrease. So actually this is actually not showing. This is actually even showing that there is an increase in the crashes attributable to the policy. Intellectually, if you're honest, this is not what you want. So let's convert, let's say, okay, control zone. How about I change the control zone to Manhattan only, but just not below 60th. The reason why we're doing this is because if we just think of the rest of the New York City as one entity and then you just compare it with everything below 60th Street, overall there is a flaw in that. What if we want to just compare everything below 60th Street and everything above 60th Street, and we just confine it into Manhattan? We might see something different. So it's red and cold. I'm just waiting. And there you go. Okay, the new analysis is shown. Okay, parallel trend visualization. To be honest, right now it looks like there is parallel trend. You could see that the green line and the blue line sort of have a similar trend of decrease at the beginning, and there's some increase around the end of year, which is not completely match. But you could see that the green line sort of has a larger decrease after congestion price has it been implemented. But note that this is small words that says it's a 7-day moving average. So I'm not sure if this is the right way to do it, but here is the difference in difference change. So treatment zone before and after difference is -3. Control zone, Manhattan above 60th Street. Difference is -2.64. All right, so difference minus difference, you could see that the estimate is -5.6. So how do you interpret it? It says that, okay, maybe this is a causal effect of congestion pricing on daily crashes. And it says that there is a reduction in crashes attributable to the policy. I am not going to comment on the validity of this causal analysis because in an academia study, it's definitely much more complicated than that. But this is a visualization, or this is a video of how cursor could be a tool that you can do data analysis while you're just being a data analysis manager. I did not write one lines of code. I did try to debug it, and then I figured that, oh, there's too much things to read. I don't want to read it. So I used the chat panel to figure out what happens. I have a hypothesis that it is the string and numeric data format that messes it up. But without me actually telling what is wrong, Cursor is able to figure it out by itself, which is very impressive. And the agent mode is also very impressive because it is all automated, including all the debugging steps. And watching it debugs itself and run itself makes me feel so good because I'm just sitting here and I'm just watching and waiting instead of, oh, if I have to do all these analysis, I'll probably take about a day or two. If I ask my intern or my, let's say a junior data analysis to do it, it'll probably take a week. So all of this is very exciting. I believe when I see that, I truly realize that the agentic era of our career or our profession has came. So yeah, this is the video about how to use Cursor to do data analysis. I am gonna do some more exploration about other agentic frameworks later, so stay tuned and subscribe. Thank you.